All right, so in 8.2, we're directly building off of what we learned yesterday with ratios. So you're going to see ratios in today's lesson, except now we're trying to figure out unit rate. And here's how it's helpful. Let's say, how many of you, your parents shop at Sam's? Any parents shop at Sam's or Costco? Why do you shop at Sam's or Costco? Okay, so you get discounts because you buy items in bulk, right? So how do you know if buying an item in bulk is actually saving you money versus buying it in a smaller package? Well, you can find the unit price. So you take the total and divide it by the quantity inside that package, and the same thing with the smaller and how much the unit price is. That tells you the savings. Does that make sense? So unit rate tells us a lot. It can tell us, it can compare lots of different units of measurement. Basically that's where we're going today. All right, so look at example 1. This is Unit Rate Basics 101 right here, okay? We've got several different types of examples. In the first one, it says a plant can grow 6 inches in 12 hours. It's like a mega plant because that does not happen, but I didn't say it's realistic. That's just what we're dealing with. So 6 inches in 12 hours. Whatever number is here in my denominator, that is the number I'm trying to get to reduce to 1. So what could I divide 12 by to get it to reduce to 1? What could I divide 12 by to get it to reduce to 1? I could divide it by 12. And whatever I do to the bottom, I have to do the same thing to the top to keep my ratio the same proportion. All right, so now I divide the top. What is 6 divided by 12? No, not 12 divided by 6, but 6 divided by 12. Nope.
2.
Nope, that's 12 divided by 6. No, it's not negative, guys. There's no negatives here.
0.
Get out your calculators. Thank you. 0.5 inches per hour. All right? So we have now written this as a unit rate because I figured out how much it grew in 1 hour. All right, now in the second example, snow fell 12 feet in 2 days. Find the unit rate. So whatever unit is down here in my denominator, I want it to cancel down to 1. So how would I get 2? What would I divide 2 by to get it to cancel to 1? 2. Whatever the bottom number is, that's what I divide top and bottom by. And 12 divided by 2 is 6 feet in 1 day. 6 feet in 1 day. All right, again, unit meaning 1, rate. Well, in the third one, it's not written as a fraction, but can I write this ratio as a fraction? How would I write it? 9 what? Cups over 5 pies. The label is everything. If you do not label on your homework, are you listening? You will get the problem marked wrong, even if you have the correct answer. You must label on the unit rate, okay? The label is just as important as the answer. So if I want to find the unit rate, what would I divide top and bottom by? I divide by 5, whatever number is in my denominator. And what is 9 divided by 5? Cups per what? Per pie. And that is how we find unit rate. Any questions on example 1? Not bad? All right, in example 2, I'm finding average speed. So again, I'm trying to figure out how fast per hour, how fast per minute, how fast per second, okay? But you need to know this formula. Average rate equals distance divided by time. Distance divided by time. Average rate equals distance divided by time. Remember yesterday when we were writing ratios for the units and it was like gallons and quarts? What did we have to do first before we could write the ratio? We had to convert them to the same unit, remember? We converted the big unit down to the smaller unit. Well, you're going to see that here. Before we can write a ratio of distance over time, our time has to be in the same unit. So we have 2 minutes and 30 seconds. Well, which one is the larger unit, minutes or seconds? minutes. So I need to convert 2 minutes into seconds. How many seconds would it be? 120 seconds plus, were there already some seconds? Yes. 30 seconds equals 150 seconds. Okay? Now that my time is in 1 unit, I can write it in my ratio. What was the distance? 1,500 meters over time, 150 seconds. All right, go ahead and find the unit rate from there. So what do I divide top and bottom by? 150. Whatever's in my denominator, I divide top and bottom by 150, and that equals what? 10 meters per second. Now let me ask you this. Is it realistic for a skateboarder to travel 10 meters in a second? No. I mean, a car maybe, but not a skateboarder. So clearly this example is not realistic. However, we did find the average speed of our super skater. He's like a superhero skater. All right. So anyway, finding average speed. You have a couple of those on your homework tonight. Last example, comparing unit rates. Now, this is our most practical example. Let's say you want to buy a candy bar, okay? Well, they sell them individually at the cash register, right? How much is a candy bar? $1. About $1? Really? I thought candy bars were more than that now, like $1.80. No, I'm talking about at the store. Okay, so let's say the candy bar at the register is $1. But you can go down the aisle and you can buy a 12-pack of candy bars for $10, okay? Well, again, in order to figure out which is the better buy, you have to figure out how much per candy bar. That's where unit rate comes in. So in this example, it's a pasta example. It says you can buy 10 pounds of pasta for $15, or you can buy 2 pounds of pasta for $3.98. Here's the most challenging part about this. Which unit are you solving for? What number goes in the denominator? Does the pounds go in the denominator or the dollars go in the denominator? Which one are you finding the unit rate for? Well, which one is it? You're finding how much money per pound. Per pound. How much money per pound? So this is 10 pounds, and this is $3.98 for 2 pounds. You want to figure out how much per pound, guys, so you can compare it. It doesn't make sense how many pounds per dollar to do it the other way. That would not get us the answer we're looking for. Okay, so go ahead and find the unit rate for both and tell me which one is the better buy. Okay, so we divide the first one, top and bottom, by 10. And how much is it per pound? $1.50, yes. Per pound. And then how much is it per pound for the 2 pound? $1.96 per pound. Okay, so which one's the better buy? The bulk pasta. Guys, that's my answer. Bulk pasta is my answer. All of the unit rates, this is all my work, okay? So here's what you can't do on your homework. You can't say, eeny, meeny, miny, I pick bulk pasta, and you show no work. You're not going to get credit. The proof is in your unit rates. I can clearly see that how much cheaper is the bulk pasta per pound. How much cheaper is it, guys? Oh, is it $1.98? It's $1.98. It's not $1.99. No, it is $1.99. Oh, goodness. All right. Brain fart. $1.99 per pound. It's still, yes, clearly the bulk pasta is cheaper by 49 cents. So you don't save much, but you do save some. All right, so if you understand that, that's everything you need to know for 8.2.